Hello everyone. In this video, I am going to explain pin diagram of 8086 microprocessor. So this is 8086 microprocessor pin diagram. This is IC. It is a 40 pin IC in which there are some pins are active high. So these pins are active high and some pins are active low. So pins with the bar are active low. So what is meaning of active high and active low? So active high pins are active when they are at logic 1. That means whenever we apply 5 volt DC voltage to that pin become active. What is meaning of active low? Active low means that pins are active whenever we apply 0 volt to that pin. So this is difference between active high and active low. Now in 8086 there are two ground pins and we have to ground these pins. There is one VCC pin, that is pin number 40, and here we have to apply 5 volt DC voltage. Now 8086 operates in two mode. One is minimum mode and maximum mode. Now what is the meaning of minimum mode? In a system, if there is a single 8086 microprocessor, then we call it as 8086 is operating in minimum mode. Remember, in any system, if there is only one 8086 processor, then we call it as 8086 is operating in minimum mode. Then what is maximum mode? In a system, if there are more than one processors in the system, then we call it as 8086 is operating in maximum mode. You can see here this is 8086 and this 8087 max coprocessor is connected with 8086. So system where there are more than one processors operating in the system, then we call it as 8086 operating in maximum mode. So for that there is a specific pin, that is minimum / maximum bar pin, that is pin number 33 in integrated circuit. Now when this pin, so this is pin number 33, which is minimum / maximum bar. This indicates that minimum is active high and maximum is active low because bar is there. That means whenever we want to use only one 8086 in the system, that means whenever we want to use 8086 in minimum mode, then we have to apply here logic 1. To this pin we have to apply logic 1. What is meaning of logic 1? Logic 1 means we have to apply 5 volt to that pin. Suppose we want to connect other processors to the 8086 microprocessor in a system, that indicates that we want to use 8086 in maximum mode. And whenever we want to use 8086 in maximum mode, this pin should be at logic 0. That means we should apply logic 0 volt to this pin. Now next is clock pin, which is pin number 19. So this is our clock pin. Now here you can see that the arrow is incoming. So this is incoming pin, means the data is flowing from outside world towards 8086. So there are multiple pins and everywhere these arrows are shown. So what these arrows indicates? Arrows indicates direction of data flow. Let's take an example of this pin. Here data flows from 8086 to outside world. Outside world means to whatever devices we connect to 8086. Now if you see this pin, it is incoming pin. That means data will flow from outside world to 8086. And some pins are bidirectional. This indicates that on these pins data can flow in both direction, that is from outside world to microprocessor and from microprocessor to outside world. Now what is this clock signal? It is incoming pin. You can see the direction of arrow, it is like this. That means data flows from outside world to 8086. So what this pin does? This pin provides timing to the processor. Timing to the processor means at this pin we have to apply this clock signal. This clock signal may be of frequency 5 MHz, 8 MHz or 10 MHz, because we know that 8086 microprocessor operates on all three frequencies. So if you want to use 8086 at 10 megahertz, the frequency of this clock signal should be 10 megahertz. One clock cycle of this clock signal is known as T state. Remember, one clock cycle, that means from this to this, is known as one T state of 8086 microprocessor. After every T state, microprocessor performs some operation, and hence it is said that it provides timing to the processor. Why it is said that it provides timing to the processor? Because after every clock cycle, microprocessor performs some operation, and hence from this frequency, even from this clock signal, we can calculate how much time is required for sending a data from processor to the memory or input output device, or from memory to microprocessor. Now next pin. Next pin is reset pin. This is reset pin. Where is reset pin? This is pin number 21. Now you can see the direction of arrow. It is incoming signal. Why it is used? It is the first of all, it is active high because there is no bar. That means it is active when it is at logic 1. Logic 1 means when we apply 5 volt to this particular pin. It is used to restart the execution. This reset pin is used to restart execution. What is the meaning of this? Suppose we want to execute two programs, that is program A and program B. Suppose we have already executed program A and now we want to execute program B. So before execution of program B, what we need to do, we need to reset the microprocessor. Before execution of any new program, the user is supposed to reset the 8086 microprocessor by sending here logic 1 like this. What happens when we apply or when we send logic 1 on this pin? It will reset registers, it will reset instruction pointer, flags, and Q in 8086 microprocessor. That means all these registers will become 0, 0. Now what is next pin? Next pin is ready. Ready is again active high signal, active high pin because there is no bar. When it is high, it indicates that device is ready to transfer a data. What is the meaning of this? Now, we know that whenever we want to use 8086, we have to connect multiple devices to 8086. We may connect input device like keyboard, or we may connect monitor like output device. So what happens? All these devices are slow as compared to 8086 because 8086 is a high-speed processor which operates on 5 megahertz, 8 megahertz, or 10 megahertz. And hence, that may create a problem while transferring a data from processor to input output device or from input output device to processor. What happens when we connect such device to this processor? We need to match the speed of microprocessor and speed of this device. That means microprocessor should transfer a data to this device only when this device is ready to receive it, or this device should transfer a data to the microprocessor only when this device is ready to transfer. Then how 8086 will understand whether this device is ready to transmit or receive a data? For that, ready pin is there. So whenever this device transfer this logic 1 on this pin to 8086 microprocessor, what it indicates? It indicates that device is ready to transfer a data. So this ready pin is used to synchronize the operation of 8086 and interfacing device, or this ready pin is used to match the speed of operation of microprocessor and peripheral device. When this pin is at logic 0, when it is at logic 0, it is low, it indicates that microprocessor should wait. It should hold on the operation. Now what is next pin? Let's start with this pin. Now we know that whenever we want to use 8086 microprocessor, we have to connect memory externally to 8086. Or we will also have to connect input output devices to 8086. Input devices like keyboard, mouse, etc. and output devices like LCD, monitor, 7-segment display, etc. So these are the output devices. So whenever we connect these peripheral devices like memory or input output devices to 8086, we need to differentiate between memory and input output devices. Whenever, so this pin, memory slash IO bar, this pin is used to decide which device is connected to 8086. That means to which device 8086 wants to communicate with. That means if we want to connect memory to 8086 and this in this pin memory is active high. So whenever we want to transfer or receive a data from memory, whenever 8086 wants to transfer or receive data from the memory and when memory is connected, this pin should be at logic 1. So why I have written here 5 volt DC which indicates logic 1, because in this diagram we have connected memory to 8086. In place of this, if 8086 wants to communicate with input output devices connected to it, in that case this pin should be at logic 0. That means when 8086 wants to communicate with memory, transfer or receive the data from memory, it should be at logic 1, and when 8086 wants to receive or transmit data to input output device, at that time this pin should be at logic 0. Next pin is AD0 to AD15 and A16 to A19. We know that in 8086 it has a 20-bit address. That means whenever 8086 wants to access a data from peripheral devices, whenever 8086 wants to communicate with memory or input output devices, it has to transfer 20-bit address to that devices. Out of that 20-bit, A16 to A19 is pure address bus, which is used to transfer 4-bit address to memory. And AD0 to AD15 is address data multiplexed bus. What is meaning of address data multiplexed bus? What is bus? Bus is nothing but wires. So what is address data multiplex bus? This is nothing but wires which are used to carry address as well as data. What this bus does in the first clock cycle, I told you this is one T state. At the first T state of clock cycle, 8086 transfers address on this pin. On the first clock cycle, on the first T state of clock, 8086 transfers address. Let's take an example that this is the data stored. This is the data stored at memory location 2005. So 1 byte is stored here and 1 byte is stored at next memory location, that is 20006. Now let's assume that 8086 wants to read this data. Read means it wants to transfer this data from memory to 8086. For transferring this data, 8086 has to transfer this address to memory. So 8086 will transfer this address on address bus. So 2000 will flow on AD0 to AD15 because these are 16 bits. And remaining these 4 bits, this is represented in hex. So in binary it is 5 means it is 0101. So these bits will flow on A16 to A19 because this is purely address bus. So this address will flow on address bus during the first T state. During the first T state of clock cycle, this 20005 will flow on address bus like this. After it goes to this, what happens? There is another pin on 8086. What is that pin? That pin is ALE. This is ALE pin, which is known as address latch enable pin. What this pin says, latch this address. Which address? This address latch which address? The address available on address bus. Who will latch that address? There are octal latches connected to 8086, that is 8282 is the octal latch. One octal latches 8 bit of address. Now what is size of our address? It is 20 bit, and hence 3 octal latches are required to store this address. Now why to store this address in the octal latch? Because the same bus is going to carry data after some time. So we need to hold, or we need to latch this address somewhere in the circuit. Who does that function? So address latch enable pin. What address latch enable? What is name of this? It is address latch enable. What this address latch enable pin does? It transfers a pulse like this to octal latch. This pulse is connected to stroke pin of octal latch. When stroke pin of octal latch receives this pulse, it will hold this address. It will store this 20005, which is 20-bit address inside the octal latch. After it holds this latch, now this bus becomes free for data flow, and this data, that is 11110000 and 101010, you can see this data, that is 16-bit data, can flow on the same bus. So what is A16 to 19? A16 to 19 is pure address bus, which is used to carry this 4-bit address. AD0 to AD15 is address data multiplexed bus. Address data multiplexed bus means same bus. Same wires are used to carry address as well as data. During first T state, it carries address, and after that, the same wires carries data. So when same wires carries data later, then this address will get lost. And to avoid this, there is octal latch. Octal latch is used to store this address, 20-bit address. But who performs this function? So there is address latch enable pin which transfers this pulse to octal latch, and after octal latch receives this pulse, it will latch this address inside. Once it latches this address, now this bus, you can see here again, this bus becomes available for data flow, and then data will flow on the same bus. So these are the functions. So this is how the function of memory slash IO bar, ALE, A16 to 19 and AD0 to AD15 bus. Now whenever we want to use 8086, I told you that we have to connect memory and input output device to 8086. So 8086 is a digital device, and hence it will communicate with these devices by sending the sequence of zeros and ones or receiving the sequence of zeros and ones. Let's assume that we want to connect memory to 8086 and 8086 wants to communicate with memory. So in that case, we keep this memory slash IO bar pin at logic 1. Now, what is this read bar pin is for? There is one read bar pin on 8086. Read bar stands for read operation. Now, 8086 functions like our brain. What happens when we read a book? When we read a book, data transfers from book to our brain. So in 8086 also, what happens in read operation? This memory acts like a notebook, or memory acts like a book. In read op, and this 8086 is brain, and this memory is like notebook. So what happens in read operation? In read operation, data will flow from memory to 8086. In read operation, what is read operation? In read operation, data should flow from memory to 8086. So whenever 8086 wants to read data from memory, it has to send this read bar signal. Now since there is a bar, it is active low. That means it is active when it is at logic 0, and it will transfer 0 to memory. So let's assume that this data, some 11110000 is stored out here in the memory. This is the address of memory location. So 8086 will first transfer this address to the memory. Now it want to read that data from the memory. So it will transfer logic 0. You can see here logic 0 on the read bar pin to the memory. And after that, memory will transfer this data on that particular location to 8086. So read bar pin is used for read operation. It stands for read signal. It is used to read the data from memory, or it may be input device, whatever we connect out here. Now next pin is write bar pin. Now what is write operation? When we write in the notebook, so how data transfers? Data transfers from our brain to notebook. Whenever we perform write operation, data transfers or information transfer from our brain to notebook. So here also this memory is nothing but notebook, and 8086 is like our brain. So what happens in write operation? In write operation, data gets transferred from 8086 to memory. So what is write operation? Write operation is when 8086 wants to transfer the data to memory. So there is one write bar pin on 8086. Write bar pin is also active low. Let's assume that 8086 wants to transfer this data to this particular memory location. So 8086 will first transfer 2003 on address data multiplex bus and address bus. And then it will transfer this write bar signal to memory. And after that, 8086 will transfer this data to this particular location. So what for write bar pin is there? It stands for write signal. It is used to write the data into the memory. It is used to write data into the memory or to the output device. That means if we connect here output device, 8086 will write into output device depending on the status of memory / IO signals, means whatever we connect out here. So it was about read bar and write bar. So these are the pins of 8086, and which pins we studied in this video. We studied this ground pin. Then we studied address data multiplex bus, that is from AD0 to AD14, and here you can see AD15. Then we studied this A16 pure address bus, A16 to A19, that is A16, A17, A18 and A19. We studied about minimum / maximum bar, then VCC, then clock, then this write bar pin we studied about read bar pin, this is ready pin, this is reset pin. And in the next video, I'm going to explain the remaining pins of 8086 microprocessor. Which are the remaining pins? All these pins are remaining pins. So these pins are used when 8086 operates in maximum mode, and these pins are used when 8086 operates in minimum mode. Remember that pins are same, only operations are different. The function of particular pin will be different in minimum and maximum mode. Pins are same, the operation is different. So I hope you understood the concept of pins of 8086 microprocessor. Remaining pins I am going to explain in the next video. Thanks for watching. Thank you very much.